that counting down over there?
Yeah.
Okay, we're live. Anybody talks today, you're going on YouTube, just so you know. Fair warning. Okay. Now we can make it a little bigger. See, that's where it goes away. That's why I couldn't get it yesterday. Figured it all out. Okay, we're going to look at two kinds of reasoning and two laws of logic today. The law of detachment and the law of syllogism. So first of all, inductive reasoning. We've already experienced this. Inductive reasoning is when you look at examples to find a pattern. And then the other kind of reasoning, and you use this naturally when you're making conclusions, it's deductive reasoning. Deductive reasoning is just to use logic to make a conclusion. So your logic could be based on just prior information, prior knowledge, some definitions, something like that. So here's 3 examples. I want you to tell me whether when they made their conclusion, did they use inductive or deductive reasoning. So here's the first situation. It says a sign in the cafeteria says that a car wash is being held on the last Saturday of May. Tomorrow is the last Saturday of May, so Justin concludes that the car wash is tomorrow. So what kind of logic did he use to make this conclusion? Inductive or deductive? It's absolutely deductive. There was no examples. He looked at the sign, took the information from the sign, applied it to the situation. That is deductive at its best. I did forget the answer line for number 2, so you're going to have to put one in there. So situation 2 says, so far, at the beginning of every Latin class, the teacher has had students review vocabulary. Latin class is about to start, and Jamila assumes that they will first review vocabulary. So is her assumption that they're going to review vocabulary inductive or deductive? Why inductive? There was a pattern established. The teacher established that pattern. You can kind of guess what's going on here every day because I establish a pattern. That's inductive when you're looking at that pattern. And then the third situation. Opposite rays are 2 rays that have a common endpoint and form a line. Ray AD and ray AQ are opposite rays. Therefore, AD and Q are collinear. Do you think inductive or deductive? You always just got to ask yourself, are there examples we're looking at? If you don't see past examples or a pattern, it's deductive. This is all based on definitions. That was deductive. Okay. Now the 2 laws of logic that use deductive reasoning. All right, there's 2 of them. The first one's called the law of detachment, which says, if you have a true if-then statement, this is if P, then Q. If this if-then statement is true, and I give you the P information, the hypothesis, then you can make the conclusion of Q as a valid conjecture. Okay, that was just a whole lot of letters with not much meaning to it, I'm sure, right? So let me use an example to talk about what's happening here. So this sentence I gave you is going to be true. If it doesn't rain on Saturday, then I will go to the corn maze. Oops. So I'm giving a hypothesis. If it's not raining on Saturday, then I'm going to go to the corn maze. Here's the next thing that happens. It's Saturday and it's sunny. Can you now give me a logical conclusion based on these two sentences? Anybody? I'm going to the corn maze. Does that seem logical based on those two sentences? I am going to the maze. Okay, because that fit the pattern. Now, don't write this. So the first sentence is still there. If it doesn't rain on Saturday, then I will go to the corn maze. Here's the second sentence. I'm going to the corn maze. Can you make a logical conclusion? Yes.
It's not raining.
It's not raining. Is that logical? Seems like it, right? Seems like you'd be able to flip that. No, that you can't say that. This could be Friday afternoon and I'm still going to the corn maze. I don't know for sure that it's not raining. I said if it doesn't rain on Saturday, I'm going. This says I'm going. This could have been Friday. This could be Sunday. Going again. Going twice, if maybe. So the point of this one is to get you to look at this pattern again. The pattern for law of detachment has to go PQP. If it's PQP, Q is your valid conclusion. Nothing else. So P was if it doesn't rain on Saturday. Q, now you can write the P's and Q's in. I will go to the corn maze. I originally gave you it's Saturday and sunny. That's pretty much this with a little different wording. That's P. So this fits the PQP pattern. So I could logically conclude the Q. Once I put this one in place, it's P, Q, then it's Q that I gave you. Law of detachment doesn't let you go back and say the first one's true. That's that converse thing. That doesn't always have the same truth value as the original one. Okay, so PQP, answer Q. Law of syllogism. I want you to think of a chain link here. This one links two if-thens together. So if you have a true if-then, and now we get a second if-then. This is where it has to be linked. What the first one ends, the second one has to begin. So this has to be the same information, then something brand new. So we got two if-thens. They have to be linked together. The conclusion here has to be the hypothesis here. If they are linked together in this order, the law of syllogism says that you can get rid of the common link and go right from the beginning to the end. Then P to R is a valid conjecture. So we're going to go back. We're going to keep this as our first if-then. If it doesn't rain on Saturday, then I will go to the corn maze. Here's the second one. If I go to the corn maze, then I'll buy a pumpkin. So did I link that correctly according to law of syllogism? If it doesn't rain on Saturday was the P, I'll go to the corn maze as the Q. If I go to the corn maze, that's Q again. Then I'll buy a pumpkin. That's brand new. Let's call it R. So based on these two if-thens linked correctly, what's our logical conclusion? It'll be another if-then statement. What's the if-then statement? Yes. Yep. If it doesn't rain on Saturday, then I'll buy a pumpkin. Okay, so those are the two laws that we want to practice with. And we're just going to practice with, are they using the law correctly? So all we're saying is whether their conclusion is valid or not. So the first one says, determine whether each conjecture is valid by law of detachment. Law of detachment, you want P to Q. Then you want P. So you want those three things. If those three things are in the right order, your conclusion is Q. So if you ride the Titan roller coaster in Arlington, Texas, then you will drop 255 feet. Michael rode the Titan roller coaster. Their conclusion, Michael dropped 255 feet. Is that a valid conclusion or invalid? What am I hearing? Invalid or valid? Let's check. Put the letters down if it helps. If you ride the Titan roller coaster, we'll call that P. Then you drop 255 feet. That's Q. There's our PQ. Michael rode the Titan roller coaster. What letter is that? That's P again. Is that fitting the PQP that we need? PQP. Did they make the right conclusion? Q. Valid. So that's all you're doing is seeing if it fits the pattern. Good? Current page. So not a lot of writing today, which is nice. Okay. Given a segment that is a diameter of a circle has endpoints on the circle. Segment AB has endpoints on the circle. Conclusion or conjecture, AB is a diameter. Gave you this one because it's a little bit different. It doesn't have the if and the then. But you could easily rewrite it in your head, or we could add the if and the then to make this an if-then statement. So you might have to change a couple little words, but you don't want to lose the meaning. Can anybody turn this first one into an if-then statement for us? So we can see where the P information is and where the Q information is. We need that to happen first. Who's going to give us the if-then? Yes.
If the segment is
Perfect. Yep. You just had to throw out the word that, otherwise it didn't make sense. So he said, if a segment is a diameter of a circle, then it has endpoints on the circle. Perfect. So let's see if this, so we're calling if a segment is a diameter of a circle, that's the P. Then it has endpoints on the circle, that's your Q. It says segment AB has endpoints on the circle. What letter is that? That's Q again. Does this fit the law of detachment pattern? P, Q, Q. No, you can stop right there, and we're going to say not a valid statement. And I could draw you a picture to show you why this conclusion is that AB is a diameter. Well, here's a circle. I can put AB that has endpoints on the circle, but I could make them not be a diameter. That's why that was not a valid conclusion. It's got to fit PQP. Thank you. Okay. Switching gears, we got 3 of these. Determining what valid or not by law of syllogism. Here's our pattern for law of syllogism. We want P to Q. Then we want the next one to be Q to R. And then if they're linked correctly, we get rid of that common link and we can go P to R. This would be our conclusion over here, P to R. So that's the pattern we're looking for, P, Q, Q, R. Are you ready? Okay. If you buy a car, we'll just throw the P on there right now. Then you can drive to school. Q. If you can drive to school, what letter is that?
Q.
That's Q again. Then you will not ride the bus. What letter is that? That's brand new, that's R. Do we have this linked correctly? P, Q, Q, R. P, Q, Q. We're good. Now they just have to make this conclusion. Are they going from P to R? If you buy a car, that was our P, then you will not ride the bus. Valid? Absolutely valid. So it's really just looking for patterns. Okay, next one. You want to try 7 on your own? You try it. What'd you come up with? Valid is, it's as valid as it comes. It went PQ, then it went QR, and they went from P to R. So that's a valid conclusion. Wonder what this next one's going to be. If 2 segments are congruent, call that P, then they have the same measure, Q. If 2 segments each have a measure of 6.5 centimeters, then they are congruent. We're back to P over here. If 2 segments each have a measure of 6.5, is that the exact same thing as saying they have the same measure? No. So if you even look at their conclusion, I could have just given you this one. You could have said false right off the bat. If 2 segments are congruent, then they each have a measure of 6.5. No. So this one's just not valid. It's all messed up. Okay, these last 2, you have to make your own conclusion. So you're either going to be using law of detachment or law of syllogism, and you're going to come up with a final conclusion. All right, if triangle LMN is translated in the coordinate plane, then it has the same size and shape as its pre-image. If you want the PQ thing, you can do that. PQ. If an image and pre-image have the same size and shape, I believe that's Q again, then the figures have equal perimeters, R. So it looks like we've got a PQ, QR linking. Triangle LMN is translated in the coordinate plane. That's P again. What can you conclude now? It went P to Q. It went Q to R. They're giving us the P. What can you finish with? Yes. And what would be the figures? So triangle LMN and its image have equal perimeters. And if you had just said the figures have equal perimeters, I would have taken that. But I was just trying to be a little bit more specific as to what those figures were. Because they gave you P, you know it's all the way to R, which is the equal perimeter part. Okay, last one. If angle R and angle S are complementary to the same angle, then the two angles are congruent. If two angles are congruent, then they are supplementary to the same angle. So I'm seeing that PQ, says angle R and S are complementary to the same angle. What can you conclude? Yes. Yep, angle R and angle S are supplementary to the same angle. So just to show you, we went PQ. It's linked with QR. They gave you P, and we finished with the R. So just like the last one, we filled in the R information. Okay, that's all I have. Page 91, 9 through 20, 23 to 26, and 28. Turn that off.